All right, we're back with part 2 here. Skill 12C. This is the last skill of chapter 12. We're looking at recursive rules. So this is now uh, rules where we need to rely on the previous or previous terms. And so we have some notation that is going to be really important. You have to have the notation correct. And then it's again just identifying patterns, looking back on the previous numbers to see how do we get the next number. So first thing I'm going to ask you to do is just show that you understand what a recursive rule is. So here's the first one. A sub n is equal to 3 times a sub n minus 1, which means the previous term, plus 4. So what I want are the first 3 terms of the sequence. I have to give you a sub 1. So in short, I want a sub 2 and I want a sub 3. A sub 2 and a sub 3. Oops. Nope, let's not get a sub 3. All right, so in order to get a sub 2, I need to use the rule and I need to plug in a sub 1 where it asks for previous term. So I will take this and I will say 3 times, looking at this now, this stands for previous term. So if I'm trying to get the second term, I want to go back to the first term. 3 times 10 plus 4. 3 times 10 is 30 plus 4 is 34. And so your second term is 34. The third term, I'm going to take 3. I'm going to multiply by my previous term, which now if I'm in the third term, the term before that would be the second term. 3 times 34 plus 4 equals 106. And that's what I'll be looking for on the first question in recursive rules. Do you understand how to plug in the previous term to get the next term? Notation. Secondly, I'm going to ask you to write some recursive rules. And here's my advice for writing recursive rules. You take a look at the second number and you say, all right, how do I get the second number from the previous number? Well, maybe I add 1. Okay, once you look at that, and then you move to the next number. Does that pattern still hold true? You can say, nope, it doesn't. There's really nothing that multiplies from 3 to 4, or at least nothing that's going to work from 3 to 4 and then 4 to 12. So then you have to look at the next number. All right, the pattern is going to hold true. So really, you can start anywhere you want. If you want to start at the last number and say, all right, look at 48. How do I go from 48 to 576? The pattern is going to be the same everywhere. So you don't have to focus on the first 2 numbers. Maybe it's easier to start in the middle somewhere. Okay, I want to look at 12. Now I have the 2 previous numbers in play. 3 times 4 equals 12. Does it work for the next one? 4 times 12 equals 48. Does it work for the next one? 12 times 48 is 576. So I'm taking the previous 2 terms and I'm multiplying them together to get this term, right? And that holds true here, 4 times 12, here, and it would if we continued on. Now, in order to write that as an arithmetic, or I'm sorry, as a recursive rule, you're going to have to use the correct notation. A sub n is equal to, I want the previous term multiplied by the one 2 back. And so I have n minus 1 is the previous term, n minus 2 is 2 back. And so I have to also at the same time tell you what those terms are, where to start. Because without this, you would have no clue where, if it was 3 or 4, if it was 100 versus 200, you need to know those terms. Number 2, what's happening here? Again, I'm going to start with the second term and see if I can figure anything out. Well, 2 times 4, or 2 times 2 is 4, so maybe it's multiplying by 2, but then I go to the next term, that doesn't work, it's less. So it's not negative, where it's multiplying by a negative number, so something else is happening. Okay, what else? How do I shrink a number? division. So we want to start thinking about division. All right, these are some of the skills you need to use as you're figuring these things out. So I'm going to skip over now. I'm going to start at 3. I'm going to say, how do I get 3 out of using these previous two numbers? Well, 2 and 4, 3 is in the middle of 2 and 4. So is it the middle number? Okay, what's in between 4 and 3? Oh, 3.5. What's in the middle of 3 and 3.5? Oh, 3.25. So it's almost like we're averaging. All right, and so I would say a sub n equals, you add up the two previous terms, and then you divide by 2. And I promise you, I will mark it wrong if you do not provide, even though they're written right up above here, I can see them, you need to tell me the appropriate terms in order to fulfill this rule. It relies on 2 terms, you must give 2 terms. Please include that. If it only relies on 1, for example, this question up here, then you only need 1 term to start the pattern. But here, if I only gave you 1 term, you would be still unsure of what to multiply together, or over in number 2, what to add together in order to find the next term. I've got 2 application questions for you here that I'd like to finish up on, or kind of depending on the timing, if you are doing this on Thursday as well. So why don't you see if you can work on these maybe for the remainder of the hour, and then we'll start with these again tomorrow, or kind of depending on how everything went. All right, I'm going to take a look at number 1 first. This is a recursive pattern. So since we just did recursive, let's start here. Write a recursive rule. So a sub n is equal to, that gives the number of trees in a given year. So they have 5,000. That's going to be your a sub 1. Okay, bamboo, nice quick growing plant. Every year they cut down 10%. So we lose 10%, but we keep, which is always what we want to focus on when we're looking at these types of problems, is we keep 90%, which means I am going to say 0.9 times the previous amount of trees minus 425 trees. Because at the end of the year, or throughout the year, however you want to do it, you, plus 425, they plant 425 more. So we lose 10%, and then we gain 425 back. All right, and so with your calculator, you can use that answer key for this. This is what you would do is you would type in 5,000 into your calculator, hit enter, so it stores it. And then what you can do is you can type your recursive rule in. You can say 0.9 times answer plus 425. And then you just hit enter. And it'll, okay, you plugged in 5,000. That's going to be your answer. And then you're going to get something out. It's going to be 4,000 975. Okay, and then you hit enter again, and what the calculator does is it says, all right, you want me to take the answer, it plugs that in for your new answer. And you can keep hitting enter, 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 and eventually you will kind of see it level off. And it levels at 4,250. Because what happens is you plug this in, you take 0.9 times 4,250, you get 3,825, and so there's less trees. But now you're going to add that 425 back here, and you end up right back at 4,205 trees, 4,250 trees. And then it's just a cycle at this point. You're never going to drop below, because as soon as you lose the 10%, keep 90, you gain back just as much as you cut down. Right? So it will level. It will always level. These recursive rules will never go to zero, as you may think. The second application question is the ball bouncing, and it's a pretty standard question. It doesn't really change much from time to time, but the numbers might. You've got a ball that's going to be dropped off a building, say. It's going to hit 123 down, and then it is going to bounce up, and it only bounces up at 73% of its previous height. Okay? And again, this won't bounce out like this. It technically is just bouncing straight up and down, but in order to illustrate this, I'm going to just draw it out. And so eventually it will stop bouncing, or it will bounce so small that it's really negligible. Right? But we want to try to sum these up, and it's technically infinite, even though we will say that the ball is not going to bounce forever. Couple of things though, it's not as simple as just an infinite sum, because we need to remember a couple of things. First, we've got this initial height. That 123 is not going to be counted into our sum. Then we only bounce 73% of it. So 123 times 0.73, this next time that bounces 89.79 feet. But it does that twice. And so you have to account for that, and we're going to have to double it. So this is our a sub 1 when we write our sum. And so we need to say we're going to sum this up now. A sub 1 is 89.79. Our R value is 0.73, and we need to do an infinite sum. Okay, so that sum is a sub 1, 89.79 over 1 minus 0.73, which is just 89.79 divided by 0.27. And so it's going to be somewhere around 332.5. I think it repeats forever, so we'll just leave it at 332.5. But that only takes care of the up. That takes care of this and this. You've summed up this part of the sequence. You need to double that number, because for every time it travels up, it also travels down that same amount. So we need to double this. So it's going to be 332.5 times 2, 665.1. Maybe 665, because we rounded that 0.5 from the beginning. And then finally, we didn't ever include this kind of all by itself, that 123, because that's not doubled. That only goes once. And so we need to also add in the 123. And finally, your sum is 700. That's a great 788 feet. There you have it.